Okay, let's start it. Here are 5 things to know about neural network in under 5 minutes. Number one, the neural network are composed of node layers. There is a input layers, and there is a hidden layer, and there is a output layer. But we can stack more layers between input and output layers to make a complicated neural networks. And these neural network reflects the behavior of the human brain, allowing computer programs to recognize patterns and solve common problems in the field of AI and deep learning. In fact, we should describing these as an artificial neural network or an ANN to distinguish it from the very unartificial neural network that is operating in our heads. Now, think of each node or artificial neuron as its own linear regression model. That is the second one. Linear regression is a mathematical model that is used to predict future events. The weights of the connection between the node determines how much influence each input has on the output. So each node is composed of input data, weights, a biases, or a threshold, and then an output. Now, data is passed from one layer in the neural networks to the next in what is known as a feed-forward network. Number 3, to illustrate these, let's consider what single node in our neural networks might look like to decide when should we go surfing. The decision to go or not is our predicted outcome, or known as a value of white hat. Let's assume there are 3 factors influencing our decisions. Are the waves good? Let's say it's x1. Let's say the wave is good. 1 for yes, 0 for no. So x1 is 1. Is the lineup empty? Which is our x2. Well, unfortunately, no. So the x2 equal to 0. And the next would be, is it shark free out there? So the x3 we say is yes. So it's 1. There's no shark attack have been reported. Now, to each decision, we assign weight based on its importance on a scale of 0 to 5. So let's say that the weights we are going to score that 1. So x1 is important, so we give it to 5 in weight. And for the crowds, there is w2. It's not that important, so we give it to 2. And for sharks, well, we will give the score of a 4, which is important. So now we can plug in these values into the formula to get the design output. So white hat equals to 1 times 5 plus 0 times 2 plus 1 minus 1 times 4. Let's move the camera out there. Then minus the biases, 3, which is our biases. In other words, we are not eager to solving today, so we minus 3. And that gives a value of 6, which is greater than 0. That is our threshold. So the output is for the node, it's 1. We are going to surfing. And if we adjust the weights or the threshold, we can achieve different outcome. Number 4, neural network rely on training data to learn and improve their accuracy over time. We leverage supervised learning on labeled data set to train the algorithm. As we train the models, we want to evaluate its accuracy using something called a cost functions. Ultimately, the goal is to minimize our cost function to ensure the correctness of fit for any given observations. And that happens as the model adjusts its weight and biases to fit the training data set. So what's known as a gradient descent, allowing the model to determine the direction to take to reduce the error, or more specifically, minimize the cost function. And finally, number 5, there are multiple types of neural network beyond the feed-forward neural network that we have described previously. For example, there are convolutional neural network known as CNNs, which have a unique architecture that is well suited for identifying patterns like image recognitions, and there are recurrent neural networks, or RNNs, which are identified by their feedback loops, and RNNs are primarily leveraged using time series data to make predictions about future events like sales forecasting. So 5 things in 5 minutes. To learn more about the neural networks, check out the following videos, and thanks for watching.